You might think the hardest problems in physics are things we haven't discovered yet, but some of the hardest problems are things we understand on paper but still can't fully explain. From chaotic air to particles that don't exist until you look, to space and time breaking apart. These are the three hardest problems in all of physics. Let's start with something you see every day: flowing air or water. Think about smoke rising from a candle. At first, it moves smoothly. Then suddenly it starts twisting, swirling, becoming messy and chaotic. And that's called turbulence. Now here's the crazy part. We already have the exact equations that describe how fluids move, the Navier-Stokes equations. In theory, these equations should let us predict exactly how the smoke moves. But in reality, even the tiniest change, like a small air current, completely changes the motion. It's like trying to predict the exact shape of every swirl in a tornado. So turbulence is hard not because we don't know the rules, but it's actually because the rules create extreme chaos. Now let's go to the next question, the measurement problem. Let's zoom into the microscopic world. In quantum mechanics, particles don't behave like tiny balls we call atoms. Instead, they act more like clouds of possibilities. Before you measure them, a particle could be in multiple states at once. This idea is called a superposition, and mathematically, it evolves smoothly using this equation. But the moment you measure it, you only ever see one outcome. For example, a particle isn't in one place until you look, but then suddenly it is. So what changed? Did the act of measuring force it to choose? Did all possibilities split into different universes? Or was it always just one outcome and we didn't know? Physicists still argue between these ideas like Copenhagen interpretation and the many worlds interpretation. So this problem really isn't about calculation anymore. It's about understanding what's actually real. Now let's go even bigger. This is one of the hardest problems in all of physics. Physics has two major theories: quantum mechanics, which explains these tiny particles, and general relativity, which explains planets, stars, and gravity. Both are incredibly accurate, but there's a problem. They don't agree with each other. Imagine using one set of rules for small things and a completely different one for big things, and when you try to combine them, everything breaks. This happens in extreme places like black holes and the beginning of the universe. The big question is, what happens when space and time themselves become quantum? Are they smooth or made of tiny chunks? Physicists have ideas like the string theory or the loop quantum gravity, but we don't yet have a final answer. So here's a pattern. Turbulence. We know the rules, but they are too chaotic to predict. Quantum measurement. We can predict these results, but don't understand why they happen. And quantum gravity. Our best theories don't fit together. Three different limits of physics, and solving even one of them would completely change how we understand the universe. If you guys enjoyed this video, make sure to like and subscribe. Be curious like a child, the world needs more of it. Bye.